Assalamu alaikum everyone. Today I am going to show you the theorem geometry part and the theorem 1. Let's start. From chapter 8 we are going to do theorem 1 and this is the chapter. This is the chapter parallel straight lines. Already you have the basic information from class 6. And if you need, then you can go through all the details here and all the symbols you need to learn. You already know about this, but this is the congruent sign. I'm going to explain what that means. That one is the parallel, which one we can also write down by like this. That is the angle sign, perpendicular sign, triangle sign. This is the circle, which one we may not be using anyway. That one is since, and that one therefore, which one is broadly used in our math and any other subjects. Okay. Before starting the theorem part, I want to tell you a few things. Normally we do for theorem, the first question they will give us, that one will be considered as general enunciation. Okay, which one is general enunciation? I'm going to tell you that one. Normally, basically write down on your book with a bold letters. Okay, then the next part, the explanation of general enunciation comes after the figure, which one is called particular enunciation. Okay, I'm also going to show you, don't worry about it. If there is any construction needed or any drawing part is needed on your geometry, on the time, that means in theorem, on the time, the part we write down as explanation, that one is an explanation, that one is considered as construction. The important part is proof. Okay, that one normally, that one is very crucial part for theorem. Okay, the main theme is based on the proof. Okay, I'm going to show you. Let's start out the first one, the theorem 1. Here, the bold letter you can see that. The bold letter you can see that part, that one is called general enunciation. Okay. If a straight line intersects two parallel straight lines in alternate angles, then the alternate angles are equal. We have to prove what? We have to prove that the alternate angles are equal when one straight line, which one is considered as transversals, and these are the two straight line, this one and that one, it intersect two straight line, parallel straight line, and then the produced alternate angles are equal to each other. This one we are going to prove. Okay, at first we are going to draw the figure first. Okay, which one I have already drawn over here. You can see that. Let me I have adjusted the zoom. Now you can see that the first part we are going to write down what? We are going to write down the general enunciation from the book. I am not writing it for now. And you can see the picture I have already drawn, how to draw it. Just put down your big scale like this, flat mode, then just draw the other two line on the top line and the second base, then just draw transversal like this. Okay, and what we are going to do in here, they said us to do what? They said us that when one line intersect two parallel lines, we are going to prove that the produced line alternate angles, the produced angles are equal to each other. So let's see what did they say in a particular enunciation. Particular enunciation, they say that let those two parallel lines are AB parallel CD. Okay, let AB parallel CD and the transversal PQ intersect them at point E and F respectively. You need to write down the respectively, definitely, because one after another. First line is AB, the second line is CD. This is why we need to write down respectively. Okay. It is required to prove that the alternate angles, doesn't matter if you take this one or that one, but normally we take this one and that one for proving the alternate angles are equal to each other. Okay, so how we are going to do that? I write down a little bit different from the book. little bit, not much. Okay, proof. Angle PEB, let's see, angle PEB, that means that one, PEB is equal to angle EFD as the corresponding angles. Okay, that one, this angle is corresponding to that angle, isn't it? So where I am writing down the corresponding angles over here, and again we can say that the vertically opposite angles of PEB is this one, isn't it? Please do not overwrite your geometry. I am just explaining, this is why I am overwriting. So vertically opposite of this one is that, which one is A, E, F, or you can say also Q. Okay, so you can see that if this one is equal to that one, and again that one equal to that one, okay, so what we can say that this one equal to that one. Okay, from this first equation and the second equation, this equal to that, that equal to that. So PEB, both of them are same. We can also write down angle EFD is equal to angle AEF. So we write down here, therefore these two are equal and they are also alternate angles. So our first part of the theorem is proved. Here another part you can see that prove that when a transversal cut to parallel straight line, the sum of interior angles of the same side of the transversal are two right angles. This one we are going to prove. I am going to do this one already over here, but I am going to show you something different. Okay, this one I am going to explain. You can see the same thing. Okay, it's the same thing. Which one is written in your book is over here also. To prove this one is, that one is general enunciation and that one is sorry, I got a call. That one is general enunciation, which one is written in your book. So there is a little bit explanation over here. To prove that when a transversal cut two parallel straight lines, the pair of interior angles on the same side, that means this is the same side and interior angles are inside. Which angles are inside? Okay, that two angles are inside the same side. We need to prove that they are supplementary. Okay, to prove two right angles, we need to prove them they are supplementary. From the class 6, maybe you remember about the supplementary. If you do not, then you need to go back and read about this. This is why I always keep saying that please do not leave your studies behind behind you when you are leaving one class. Okay, so particular enunciation, again the AB parallel to CD, this is how we write down in a short, and PQ is a transversal which intersect at E and F respectively. The one side of the transversal, on the one side of the transversal PQ, interior angles will be this one and that one, same side, and interior, that means internal. Okay, internal, which is inside the parallel lines. Okay, they gave you BEF, the BEF, and also EFD, and we need to prove that. That side, that one you don't have to write down. This one and that one you don't have to write down. You can only prove one thing, that would be fine. Okay, so we need to prove what? We need to prove that one plus that one makes supplementary angles, or we can say 180 degree or two right angle. Okay, I'm not writing it, but you can do it. So you can see that EFD is corresponding angles of PEB. So let's see, EFD is corresponding angles of PEB. That one and that one, both of them are equal. Okay, because they are corresponding angles and the same side, same direction. Okay, facing same direction, never forget that. Same side facing same direction, that makes them corresponding angles. If they are different side facing different direction, that means they are alternative angles, which one already you have seen few minutes back. Okay, the video is getting longer. And now if we plus BEF plus EFD, which one we need to prove? Then we can replace that EFD with PEF because both of them are equal, as we said. So we can get angle PEF, or we can say also Q, doesn't matter. This whole angle is a straight line. That means it's one straight line, two right angle. So already proved that both of them are having. You can write down over here the proof. You can if the question got changed, then you can adjust yourself and write down whatever the question required for.